Hey guys, how's it going? On the last video, we spoke and we learned how to build the basics of a container. That is, how to register and how to fetch dependencies out of the service container. On this lesson, we're going to learn how to actually let the container resolve dependencies for us. So for example, if you want to resolve a class that is not registered in the container, like we do all the time with Laravel, or if you want to not only instantiate a class that is not resolved on the container, but also let the container fetch its dependency for us. That is, do what we call dependency injection automatically. This is the primary job of a dependency injection container, hence its name, dependency injection container. And we're going to learn how to do that on our custom container on this lesson. So check it out. I hope you guys enjoy it. Let me know in the comments whether you liked it, whether you hated it, what things could I have done better. And also make sure to subscribe to this channel. That helps me immensely. And also follow me on Twitter, all the jazz. You know about it already. All right, so let's jump into the coding, and I see you guys soon. Bye-bye. I mean, not bye-bye. I'm going to see you guys on the coding piece. See you soon. All right, let's continue from the last video. This is where we left off. We're able to register instances to our container. We are able to fetch instances, and we can determine if an instance exists within the container. The only change I've done is adding this TDD function, which just dumps whatever we pass to it and then exits the script, just so we can debug things a little bit easier. If we run our tests, they are still passing. So for this lesson, I like us to be able to do two things. First, I want us to be able to resolve classes that have not been registered to the container. For example, in Laravel, you can always do something like resolve and pass your own class here. And this class might not be registered as a service within the container, but Laravel will resolve it for you nonetheless. The second thing is I want this container to do one of the most important jobs a container has, which is dependency injection. So determining which arguments need to be injected into a given class and doing that for you. So for example, let's go into our container test. And let's write two simple classes. The first one is going to be called ORM. And just imagine this is an ORM. The second one is going to be called user. And this user class is going to have a constructor. And we are going to inject our ORM class right here, like this. So now we have a user class, which depends on an ORM class. This user class is not going to be registered on the container, but the container should still be able to not only fetch it, but also pass its dependencies. And in this case, it's only the ORM. All right, let's start with what's easier, which is fetching a dependency that's not registered on the container. And we can use this ORM class for this. Let's write a task called test if fetches unregistered dependencies, or rather services. This returns void. And this test is really simple. We want to make sure this is an instance of ORM, and we're going to call the container. You want to get an instance of it, and we're going to say, hey, give me an ORM like this. All right, I am going to run PHP unit, and you can see it's failing. It's obviously not finding an instance of class ORM, and we're also getting a warning. So let's run this. Let's run PHP unit. So vendor bin PHP unit. And pass it with warnings flags. Sorry, it's called display warnings. And you can see we got an undefined array key. So the problem is PHP does not throw an error for this when we try to access a key that does not exist. It only gives us a warning. PHP does let us know that we had a warning on our test suite, on our code base, but it doesn't actually tell us what it is unless we use the display warnings flag. So if we go to the container implementation, it's pretty clear why we have this. So we're trying to access this key called ORM. It obviously does not exist within the services array, so it's throwing that warning. Fixing it is really simple. So we can do something like if this has, so in case the container has that service, let's add an if block, oops, not meant to get rid of this. Let's put this in an if block. So we only want to do this if the container has that service. Let's rerun PHP unit. Okay, now we're not getting a warning, but the task is still failing. We're not able to resolve a dependency that does not exist within the container. Fixing that is really simple. We can do something like return new ID. So let's try that. Okay, it works, so we're getting somewhere. But now think with me, what if I pass a class that does not exist? So let's say we want this task, it throws an exception if we pass a class, or rather a service that does not exist. What we want to use here is the expect exception method. And the exception that we expect is, let's take a look at our PSR 11. We want to throw a not found exception interface. So let's go with, we want a not found exception interface like this. And then we just want to call the container with something that does not exist. So something like get my class that does not exist. So that's an edge case already. Let's try that one. Let's run this. It fails. We're not passing an exception. We're not throwing an exception. We're simply getting a class, my class that does not exist, not found. So that's a good enough-ish error. It's an error. It clearly illustrates the problem, but we can also add a check to make sure that the class we want to check exists. So we can say class exists, and we can pass the ID. If it exists, we can return a new instance of it. If it doesn't exist, we can throw an exception. So something like service, or rather class does not exist exception. And one already exists for the PHP unit render. So let's call it could not resolve class exception. Something like that. For now, let's go with that. We can change this later if we wish to. So throw new. I want to create this class. It's going to be under container exceptions like this. All right. We can get rid of this container, and I want this to extend exception or runtime exception. Okay. We also wanted to implement the, what is the name of it? Not found exception interface. Okay. Something like this. Maybe this is not the best name for this exception, but let's go with it. We just want to keep moving forward. So let's run this. Okay. Now we're passing. So if the class does not exist, we throw an error. Okay, so we already got one problem out of the way, which is resolving services that are not registered within the container, like this one, the ORM. We've never really registered it. Now, the second problem is, what if we have something like this user class? So we can resolve the user class, but can we resolve this ORM object? I don't think we can. I mean, based on the code we have, if we try to resolve this, like, you know what, let's see what happens. I'm going to create a task, really simple task. And on this task, all I want to do is fetch this user. So container get instance. I want to get a user, right? Pretty standard. And then I want to make sure that the ORM instance within this user class is resolved. So we can say that we want this to be an ORM instance, and we're going to say user ORM. So we want the user property on this user, the ORM property on the user object to be an instance of ORM. So let's try running our test. Okay, it obviously does not work because right here, we are just newing that instance. So we're getting a user class here and we're just trying to new it. Obviously, it doesn't work because the constructor requires us to pass an ORM. All right, this is where it starts to get fun. How do we instantiate the dependencies of a class? That's where things start to get a little bit complicated. So I'm going to replace this with a method call. I'm going to call it build. So we want to build a service. I'm also going to rename this from ID to service because right now we're not only dealing with identifiers within the service container. We're dealing with arbitrary things like class names. So we're going to say service just to make it a little bit easier for us to read. And we want to build a service. So let me create this method. It's going to be protected. If you're not familiar with the reflection API, you might need to pause this video at some points and go through the documentation just so you can understand it. But we're going to use something called the reflection API. And what the reflection API does is it gives us information about things we have in the code. So for example, if we have a class name, we can give it to the reflection API, and that reflection API is going to tell us a little bit about the class. What are its constructors, what its name is, which interface it implements, etc., etc., etc. It is a very extensive API, and it comes very handy in several situations. So if you have never played with it, I highly suggest that you go to the documentation and just take a look at it. There are lots of fantastic things you can do with reflection. All right, so the first thing we want to do is I'm going to copy the name of this task so that we can filter when running our task. So we can say PHP unit, we want to filter. Let's pass the name. Obviously, it's still failing. But let's start using this dump and die. So if we dump and die this service, let's take a look at what we have. All right, so we have a string called user, right, which is the name of the class. If we were to namespace it, for example, if we were to say tasks and rerun this, we now got tasks / user. So this is just the fully qualified namespace of the service we're trying to access. And the reason is we're passing it with the class notation. So this just gives us the fully qualified namespace. All right, so the first thing we want to do is we want to get the reflection class. We're going to call this reflector. We can say new reflection class. That's it. And pass in the fully qualified namespace. Now, if we dump and die this, let's take a look. All right, we got an object of reflection class, and there are lots of things we can do with this. Obviously, you need to go into the documentation to see all of it. I'm not going to showcase it all. First, because I don't know its entire API. I've never really played a lot with it. And secondly, because this video would get very extensive. All right, with this in hand, one cool thing we can do is we can fetch its constructor. So we can say constructor equals reflector get constructor. So now we have the constructor. And within the constructor, we can get the parameters of that given constructor. So we can say parameters is constructor get parameters. This is going to be important where it says that no pointer exception may occur here. We're going to use this in the future. Just remember this. All right, so we have the parameters. If we run a DT on the parameters, let's see what we have. Okay, we have an array and we have an object reflection parameter right here, which has a property called name. Cool, that gives us some context already. Name is this variable right here, this property. Okay, so what can we do with this? Now that we have the parameters, we know how to resolve them. For example, if I fetch the first parameter like this, okay, we get the first object of the array. All right, so there's something that we can use here. Let's go here and say that we want to get the type. So if we type this, we get a reflection name type. And within this object, we have another very handy method called getName. So let's run getName and see what we get. Okay, we got ORM. Let's do a test. What if we namespace this? Are we going to get, for example, task / ORM? So let's say task. Let's run this. Okay, so we get the namespace of that. And this is exactly what we want. We want to fetch the type, the class that this is dealing with. Of course, we're not limited to passing a class. We could pass a primitive, right? We could pass a closure. For example, we could pass a string, but we're going to deal with that later. For now, we're focused on this. We want to learn how to instantiate that kind of thing, classes. We want to give objects to those dependencies, to those services, really. All right, cool. So let's think about one parameter first. So let's say parameter equals the first of the parameters. The class would be parameter get type get name. Another no pointer right here. Keep this in mind. Now that we have the class, we could do something like if the class exists. So if class exists, then we can return the service and pass it to it. Something like that. So let's try that. String given. Oh yeah, sure. Sorry, we have to new it as well. So let's say new here. And it's passing. Okay, cool. So that's something. But what if we have multiple parameters, right? That's a situation. So let's go here and pass something else. So let's say we want to test, it injects multiple dependencies. Be void. We're going to copy this and let's create another, I don't know, something else. We're going to say, let's go with user builder, which doesn't really mean anything. And we're going to say construct. And here we're going to expect a test service, which is the class we created. So test service, we want this to be public. And we're also going to expect an ORM. Now you might be thinking, okay, could you maybe choose user and ORM? I could, but on user, we would have a larger dependency graph because user builder would depend on user and user would depend on ORM. So we're going to talk about this later. Let's keep it simple for now. So let's go with this. And we want to say, we want to get a user builder, right? So user builder like this. Oh, it was missing a column. And we want the ORM to be that. And we want the test service to also be test service like this. Call this user builder. All right, so we have one more task to play with. Let's play with it. So let's filter this. It obviously fails. We only pass one argument to the constructor it expects to. So we can just, since we know this is an array, we can just put this inside an array. So let's say something like that. We want to say that the resolve dependencies is, and we can map this array. We already know it's an array, right? We already know that we have each dependency that needs to be resolved within the array. So we can map it. We can pass a function. On that function, we get a reflection parameter like this, okay? And the array is the parameters array. Cool. So as you can see, it is a reflection parameter, just like we were dealing before. And now we can just replicate this here. So we can say that the class is the parameter. We want to get the type. We want to get the name. And then if the class exists, we can return a new instance of the class. Obviously, we can get rid of this. And now we have our resolved dependency graph. So let's dump and die this as well. Okay, we got an object test service and we got an object ORM. That's exactly what we want. We want the resolved objects. We want instantiated classes, instances of those classes, I mean. So now that we have that, we can use a handy reflection class method as well. We can return reflector, and it has this class called new instance args. So we can instantiate a new instance of it with the args that we have, the arguments that we have. And you already have them in an array. It's a resolved dependencies array. So let's say resolved dependencies. Okay, let's run the test, and it's passing. Okay, so I think we nailed this. We're able to return exactly what we want. We can just say that we want to return an object here. If I run all the tests, something broke. So let's follow the error trace. Let's go to container 68. Okay, here's the problem. You see how we have a no pointer exception here? So when we try to resolve something that doesn't have a constructor, for example, ORM or test service, sure, test service is registered on the container, on the test we have, so it is going to skip this piece, but ORM is not. And by the time this is getting called, it's getting a no parameters array. I'm sorry, it's not getting an array, it's getting null because it doesn't have a constructor. So to fix that, there are two ways. We could either check if this is null, so something like that. If parameters is null, then we just want to return a new instance of the service. So let's try it. I'm sorry, this would still pass in no, my bad. It's the constructor that's no, it's not the parameters. So we can kill this and put it here. And we can say, if the constructor is no, then yeah, we don't really need the parameters. So let's do this. And if we run it, okay, the tests are passing. I think a better way to do this is without changing the flow of code. So since we have this, which could be no here, we can do this here. This is called the no safe operator. So if the left hand of the operator is no, it's just not going to do anything. If it exists though, it is going to execute what's in the right. And you can also use this in array. So it's pretty handy. So we can do this instead. And if we try to run this, it's still going to fail because this is supposed to be an array and we're passing no. But what we can do is we can say, if we have the parameters, let's keep that array. If we don't have that though, let's just use a default empty array. So the code is still going to execute this, but since this array is going to be empty, this map is never going to run really because it doesn't have any set of data to run on. And then we're just going to call new instance args with an empty array. So if we run this again, it's passing, and we can refactor this a little bit. We can say parameters equals reflector, get constructor. We can use the no safe operator here, get parameters. If we don't have them, we want an empty array like this. Let's run it. There we go. So it's still passing. All right, cool. So we got something in this lesson. We can now build objects that are not registered within the container, or rather build classes that are not registered within the container, and also give them their dependencies. Before we wrap this video, let's finish it off with a new problem. Let's create a task. First, let's create a class. So the class is going to be called create user account, right? And this class, it is going to use two things. It is going to use a user. So we can say public user, and it's also going to use the test service. I'm going to call this service. And let's write a task for it. So let's say test, it injects multiple dependencies. Sorry, you guys know that English is not my first language, so sometimes I forget words. But what I mean here is a dependency that also has a dependency that needs to be resolved, and so on. So I would say multi-level dependencies or something like that. You guys are going to give me a better word for this. Leave it on the comments because I cannot think of it right now. So, okay, so what we want is really pretty simple. Let's copy this. We want to fetch a container and we want to run this against create user account. So this is going to be, let's call it action, right? And we want the action. It has two parameters, right? User and test service. So we want user to be an instance of user. We want user ORM to be an instance of ORM. So this is still levels deep, right? We're not really looking only for the dependencies on the first object. We need to build all of them. And then we want action service to be test service, something like that. I think this is it. Let's try running this. And obviously, it blows up. It explodes. As you can see, the problem is we are resolving the user dependency, which is right here, but we cannot resolve the user dependencies. That is, we can resolve this one, we can view it, but we cannot give the ORM to it because as you can see right here, we are only doing that for the dependencies on the class we're trying to build. We need to do this on the class we're trying to build and also on the classes that the class we're trying to build uses. So on its dependencies. So just think of this kind of like recursion. We could use recursion to this problem exactly. But yes, that's pretty much it. We want to build the top level class and also all the classes as we go down the rabbit hole. So all of its dependencies and all of the dependencies of its dependencies and so on. We need to build the entire dependency graph. And that's what we're going to do on the next video. You know what? No reason to postpone it since this is pretty simple. All right, so we got that failing task. Obviously, we need to resolve the other dependencies. Let's take a look at this code. So this block of code, this piece of code only executes when we have parameters. If we're passing a class that does not have any parameters to be resolved, that is the last class of this chain of classes to be resolved, this is not going to be executed. So what if we replace this with calling the function itself? So yeah, just a recursive function. It just calls itself. And since this is not going to run on the last class of the chain of the graph, it is not going to call itself forever. It's going to stop at some point. Let's try this out. It works. So now we got our tests passing, and we can also inject multi-level dependencies, if that word makes any sense. All right, I hope you guys enjoyed this video, and I see you on the next one. See you later. Bye-bye.